Welcome to EDU World Space.
In this question, we are given this setup. Car A is traveling around a curve at 10 meters per second, increasing its speed at 5 meters per second square. And then car B is moving to the right with a speed 18.5 meters per second, and the speed is increasing at
Here's
2
a clean
meters
and
per
professionally
second
formatted
square to
presentation
the
of the
right.
calculation shown in the image.
So we want to find the velocity of A relative to B
Application
and
of the work energy
acceleration
theorem,
of A
wet.
relative to
From the
B.
work energy theorem, the force F is given by
solution.
F equals
To do
frac
this
text
problem, first
KE,
is
where
to
KE
write
equals
down
kinetic
the
energy, S equals
velocity of
stopping
A and B
distance.
in vector
I'm
form,
given for
as
object
well as
A,
acceleration
FA
of
equals
A and
frac
B in vector form.
100,000, 0.10.
So
For
velocity of
object B,
A,
FB equals frac
then we
225,
can find the relative
1500
velocity
equals
easily.
0.15 text space
So
then.
velocity of
And
A
force
is
ratio
10
frac FA,
times
FB equal
cosine
frac 0.10,
45 degrees
0.15 equal frac 2
I
null
hat
result.
minus
I'm a box frac
sine
FA,
45
FB.
degrees J
Would you
hat.
like a PDF
So this
version of
is
this
5 root
explanation?
2 I hat minus J hat, and then VB is equal to 18.5 I hat. Okay, so units meters per second, meters per second. So velocity of A relative to B by definition is velocity of A minus velocity of B. Okay, so we have 5 root 2 minus 18.5 I hat minus 5 root 2 J hat. Okay, and then in numbers, evaluating the numbers, you get negative 11.43 I hat minus 7.07 J hat. Okay, meters per second. Okay, so the magnitude, okay, you just take the square root, use Pythagoras theorem, so you square the components and you sum them, and then you take the square root. Okay, so this is what you get, is 13.4 meters per second. Then the direction theta is equal to tangent of the y component divided by the x component. Okay, and this angle is 31.7 degrees. Okay, so how do we visualize the 31.7 degrees? This is our velocity of A relative to B, and then this angle theta is 31.7 degrees. Okay, so this is the magnitude of the relative velocity. Then this is the direction of the relative velocity. Okay, next we will proceed to do the acceleration part. So we are given that the magnitude of the tangential acceleration is 5 meters per second square. The car A is speeding up, and then the normal component of car A, the acceleration of car A will be VA squared divided by the radius R. So the speed is 10 square, and then the radius is 100 meters. Okay, so you get 1 meters per second square. So the vector in vector form, the acceleration of A. Okay, so this is the tangential component, and then you have the normal component. Okay, and then just note that this is 45 degrees, this is also 45 degrees. Okay, they are 90 degrees to each other. So the vector in vector form, we have 5 cosine 45 degrees. Okay, so this is 5, and then this is 1. Okay, and then 5 cosine 45 degrees minus cosine 45 degrees I hat. Okay, plus negative sine 45 degrees minus 5 sine 45 degrees J hat, and then you evaluate the numbers, you get 2.83 I hat minus 4.24 J hat. Okay, and then for the vector form of the acceleration of car B is 2 I hat meters per second square. Okay, so repeat the same steps for finding relative acceleration. So acceleration of A relative to B is acceleration of A minus acceleration of B in vector form. So you get 0.83 I hat minus 4.24 J hat meters per second square. Okay, so the magnitude is equal to 0.83 square plus 4.24 square, and then take the square root of the sum, and you get 4.32 meters per second square. And then the angle theta is arctangent, the y component 4.24 divided by the x component 0.83, you get 79.0 degrees. Okay, so this is the relative acceleration of A respect to B, and then this angle is 79.0 degrees. Okay, so this is the magnitude of the relative acceleration. This is the direction of the relative acceleration. Okay, and that's all.